Hi, let's solve the second question from today's weekly contest, that is minimum time to revert word to initial state 1. So in this question, we are given a zero index string word and an integer k. And at every second, we can perform the following operations. So what are they? They are removing the first k characters of this string and adding any k characters to the end of this string. Now, you do not necessarily need to add the same characters that you removed. Basically, you can add any k characters. You have to remove first k characters and you can append any k characters to this word string. And these both operations must be performed simultaneously, that is at every second. And we need to return the minimum time greater than 0 required for word to revert to its initial state. Basically, I have to tell minimum number of times I have to perform this operation to make this word string become equal to it only. All right, that is whatever it was initially, we make the string same. All right, so let's understand this test case. So the first test case is a b a c a b a and k given to us is 3. All right, now what we are basically told in the question is we can remove first k characters. If I remove ABA, I get CABA and I can append any 3 characters to the end of this string, any k characters, right? So here it is 3. So that is what one operation is. So I have to tell the minimum number of operations that I have to perform, correct? So now if you, the only catch in this question is if you do not spiral down into thinking what these characters would be, the question is much easier, right? If you try to figure out what these characters will be, then it seems to be a difficult question. But if you do not think about these characters, then this question becomes relatively easier, because then you can clearly observe that if, let's say, this is my remaining string, right? If all these characters match to the original string characters, the first 4 characters, so because in the remaining string I have 4 characters, the rest characters I can put anything, so I can put ABA here only. But if the first 4 characters here match, then that means I don't have to perform any more operations, right? So here I would have gotten an answer, and that you can clearly see here also. Let's say, so here we can see that these two are not matching, that is the remaining and the original string. So I will perform this operation once again. So if I perform the operation once again, so I'll remove CAB in that case. So I'll be left with A only. So here I can insert any 3 characters. So this is from operation 1, this is from operation 2. Now if I see my remaining string and if I compare it with the original string, right, the same length, right? So if it is of 1 length, then it should also be of 1 length only. So they are matching. So that means I do not have to take these 3 characters and again, try to append it. Instead, here I can simply return an answer, which is 2 operations. Similarly, it will be more clearly seen in this case when k is 4, right? So here we will do one operation. We have to do one operation, right? 1 is the minimum number of operations because the number of operations cannot be 0 here. So if we do this, then we will be having ABA and K characters appended to the last. So now if you check these characters and if you check the original string, they match, right? So that means I can have CABA here, and now both my strings match. So that means I only have to perform one operation in this case. Similarly, let's take the third test case. The third test case is ABCB, ABCD. So we have A, B, C, B, A, B, C, D, and K given here is 2. All right. Now here let's try to perform these operations and try to figure out how many operations we have to, what is the minimum number of operations we can get. So I will remove these 2 characters, that is AB. So we will have CB, AB, CD here, and 2 characters appended here. Now if I try to compare this string with this whole part, then I can see they do not match, right? So I have to perform another operation. So then in that operation I will remove CB. So I will have AB, CD, and two more characters appended. So now again, if I check these four characters with the original string's four characters, then again they do not match. So I have to perform this operation again. So I will remove AB. So now I'll be having CD in the last. So if I compare CD with AB, then again they do not match. So I have to perform one more operation. So in that operation, I will be having all these as blanks, right? So here I can see that the minimum number of operations I have to perform is 4. So basically we are wiping out the whole string here, right? And then we are getting the operations, number of operations, right? So this is the basic intuition for this problem, right? So as I said, if you had tried to think about what characters to insert here, the problem would have seemed quite complex, because initially I also did that. But after you forget about these three characters, because they can be anything, right, and focus on the problem, then the intuition is very easy. So now let us go ahead and code it out. So basically I'll describe what we are going to do here. So what we will basically do, we will be only taking these blanks and we will be filling this with hashes. All right. So what we will basically do is we will take the remaining string. So we will cut out these characters, right? First k characters, right? So first we'll store the original string somewhere, and then we will be doing changes in the word string only. So inside of that string, what we will do, we will take the rest of the string, that is starting from kth index, right, up to n, that is the size of the string. So we take those characters, so we have this, then we append this hash string that we will make. So these will be k number of hashes, and we will append it to this substring that we get from the original string. Then what we'll do, this will be our word string. All right. Then we will check whether these four characters match with the original string's four character, right? And that we will do inside of a check function. So here we will simply pass what is the current string value and what is the original string values. And if the characters are not hash, then we have to compare if all the characters are matching. If the characters are matching, then I can return true, right? If they are not matching, then I will return false. And if it is a false, that means I have to perform an operation, right? And if it is not a false, then I can return the answer, right? So let us go to the code. So here is the check function that I have implemented. So inside of this check function, I have the original string, the current string, that is the string I get after making changes, and the size of the array. And here I am simply iterating to check if where this is not followed, right? Where the current string does not have any hashes, those characters do not have hashes, I have to check the remaining string, right, and compare it with the original string. If they do not match, simply return false from here. If they match, then return true. Now let's come to the main function. So inside of this function, we have taken inside of this original string variable the word, and inside of word we will be making these changes, that is appending hash, right, and taking the substring. So here I can see that all right, so this is hash, then we have taken this answer and the size of the array, then we are making this hash array here. So basically hash array contains k number of hashes in it that we are using for appending. Then we are iterating in this while loop, and here we are calculating this word according to our logic, that is we are taking the substring starting from the kth index and we are appending these hashes here, right, because we don't know what values we have to insert. After that, we are simply doing ans plus plus, that is we are calculating the number of operations. So this will store the number of operation. Now what I will do, I will check this original string with the word string, right, which is the current string after making the changes. So if they match, right, if this function returns true, that means they are matching the remaining characters, then I can return the answer. So that will be my minimum number of operations. Now if you are wondering if this loop goes for infinite times, it will not, because see, in this case what we saw, all the characters became hash. So when such a condition would arrive, this function would return true. So that means we will be terminating this loop. So that is the basic logic of this problem. So I hope you have understood it.